Hi, this is page 9 and 10 of your homework packet. Tonight you're going to be asked to calculate the molar mass of a compound. This is how much 1 mole of that substance weighs. The molar mass is simply the mass in grams of 1 mole of a substance. In the first example here, we have magnesium chlorate. You can see that we already filled in the quantities for you, but the expectation is that you would be able to do that on your own. Here it's showing you have 1 magnesium that weighs 24.305, 2 chlorines that weigh 35.453, and 6 oxygens. Anytime you have parentheses, the small number on the outside will distribute only inside the parentheses. So you're going to need to pull out your cell phone for a calculator. 1 times 20, okay, I am not going to insult you by typing that into the calculator, because anything times 1 is the same thing. And 2 times 35.453 gives you 70.906, and 6 times 15.999 gives you 95.994. So this is the mass of each of the individual components. Now we're going to add those together. 70.90 plus 24.305. And that gives us a total molar mass of 191.205. And that's the mass of 1 mole of magnesium chlorate. In this exercise, we'll also ask you to figure out what the percent composition is of each substance. To calculate a percent, you take how much the part weighs, divide by the total, and multiply by 100. So in this first case, it's 24.305 divided by 191.205 times 100. So I'm going to do 24.305 divided by 191.205. And you can go ahead and do it all in one step in the calculator. So the first one is 12.7%. That's the percent of magnesium in the compound. You would do the same thing to calculate. Zoom in for y'all so y'all get to see a little bit better. You would do the same thing to calculate chlorine, except you would use chlorine's mass. 70.906 divided by the total, which is 191.205 times 100. 70.906 divided by 191.205 times 100. So that would let us know that chlorine makes up 37.08, which we'll just say 37.1%. And then the last one, we would just say that oxygen in this compound weighs 95.994 divided by the total times 100. 95.994 divided by 191.205 times 100. Okay, 50.2% of the compound is oxygen. Now this next step, you're actually done with the problem at this point, but I personally, if there's a way to check my answer or see if I ballparked this correctly, I want to make sure that my answer makes sense. If you add up your percents, you should, in a real-world situation, get 100%. So I'm just going to add these three numbers, 12.7 plus 37.1 plus 50.2. and I got 100%. So I'm very satisfied with that answer. Yay! Now if you get 99.9 or 100.1 or something very, very close to 100, your answer's probably right, but for some reason when rounding it got a little bit off. But that's how you calculate a percent composition in a formula. So you'll do that same process on the next two blocks. The page 10 on the back, you're doing the same thing, we're just not giving you that nice structure. This was more for learning how to do it. This is more, let's see if you can do it on your own. So the first thing you're going to have to do is you're going to have to write a formula. So you're going to have to crisscross and come up with your formula. So magnesium would get the 3 from phosphate, and phosphate would get the 2 from magnesium. So in this formula there are 3 magnesiums and 2 phosphates. The next thing you would have to do is calculate the mass. There's 3 magnesiums that weigh 24.305. There's 2 phosphorus, 30.974. And there's 8 oxygens, which weigh 15.999. Now, since we have to do percent composition anyway, it would be wise to go ahead and have 3 separate answers here that you actually write down. So I would write 72.915 grams of magnesium, (61.948 grams per mole of phosphorus, and 127.992 would be the mass of 8 oxygens. Then the molar mass is when you add all of it up. So 262.855 grams per mole. Now, just like on the other side, we're going to have to figure out the percent. So in this compound, magnesium weighs 72.915. We're going to divide that by the total mass, and we're going to multiply by 100. 72.915 divided by 262.855 times 100 gives me 27.7%. We'll do the same thing for the phosphorus. 61.948 divided by 262.855 times 100 gives me 23.6. Now, if you're real confident and you get a little cocky, some people just do 100 minus these two percentages and they can calculate the oxygen that way. Meaning they would have said 100 minus 27.7 minus 23.6, and your answer would be 48.7%. I'm a little hesitant myself in doing that, because what if I messed up something in one of these calculations? Then everything would be wrong. So I'm going to go ahead and just make sure that 127.992 divided by 262.855 times 100 would give me that 48.7. And sure does. All right. So the rest of the problems you'll work just like that. Just make sure that if it's an ionic compound, that you crisscross. If it's a covalent compound, you just write it like you see it. So I'm going to give you some formulas to work with. So this would be AU2 SO3 3, because you have to crisscross gold and sulfite. And then the last one here, the last formula, cobalt is +3, permanganate is MnO4 -1. So when you crisscross the 3 and the 1, you get CO MnO4 3. Thanks for watching.